Hello friends. In previous video we had learned about distance time graph. In today's video we will learn about velocity time graph. If you want to understand better, you go and watch my previous video distance time graph. In that I had explained different kinds of DT graph. Graphs are kind of easy. Let's discuss velocity time graph. I will show you three types of velocity time graph. First type, second type and third type. Let's understand first type of velocity time graph. Here we will take Cartesian plane with x-axis and y-axis, the time along x-axis and velocity along y-axis. Now we have a box here in which velocity and time are given. Velocity of a moving body at some instant of time. So here you can observe velocity is in meter per second and time is in seconds. We will be plotting all the points in the graph and joining all of them we get a straight line which is parallel to x-axis. You can observe here in 10 seconds 30 meter is covered. We have taken time on x-axis and velocity on y-axis. So in 10 seconds 30 meter is covered. Then in 20 seconds 30 meter velocity is covered and so on. After plotting all the points and joining them, we get a straight line which is parallel to x-axis. So you can notice here that the velocity of the body is not at all changing throughout the journey. You can observe here velocity is 30 meter per second only. Velocity is neither decreasing nor increasing, only 30 meter per second throughout the journey. So the velocity of this body is a uniform velocity. Whenever there is a uniform velocity of the body, we get a velocity time graph which is parallel to x-axis. On graph you can observe that the line is parallel to x-axis. What is the acceleration? What about the acceleration? We all know that acceleration is defined as the rate of change of velocity. But here the velocity is not changing. There is no change in velocity, so there is no acceleration at all. The acceleration here will be 0. So whenever we see velocity time graph which is parallel to x-axis, we can conclude two things. First, the body is moving with uniform velocity. Second is it is moving with zero acceleration. Velocity with zero acceleration. Let's understand second type of VT graph. Velocity time graph. On the graph you can observe that the line is not parallel to x-axis. It is a straight line. In the box, time and velocity are given. The time is in seconds and velocity is meter per second. So in 0 seconds, 0 meter is covered. 10 seconds, 10 meter is covered. In 20 seconds, 20 meter is covered. And so on. Velocity is increasing 10 meter per second. You can observe here that velocity is increasing by 10 meter per second in every 10 seconds. So we can say that the body is moving with a velocity which is uniformly increasing velocity. Now what about the acceleration? Well, we said that velocity is increasing uniformly. We know that acceleration is the rate of change of velocity. But here it is uniformly changing, which means acceleration is constant in this case. So whenever we see velocity time graph is straight line and not parallel to x-axis and uniformly increasing, then the acceleration is constant. So whenever we see velocity time graph, which is a straight line not parallel to x-axis and uniformly moving with a uniformly increasing velocity, then the acceleration is constant. Look, graphs are easy. You have to just understand it. Let's move to the third type of graph. This graph is again a straight line, but it has a negative slope. So this kind of velocity time graph means that there is a body which is moving with uniformly decreasing velocity. You can observe on the graph, on x-axis time is in seconds and on y-axis velocity is given. The slope is negative. Here the body is moving with uniformly decreasing velocity. So whenever there is a decreasing velocity, we call it as negative acceleration or retardation. So in this case, acceleration is constant. Slope of this line is negative and straight line. So this was all about velocity time graph. We have looked at different kinds of velocity time graph. The velocity time graph for uniform velocity, uniformly increasing velocity and also uniformly decreasing velocity. And I hope this video was fully understandable.